All right, let's dive into the unsung hero of software performance, the database index. Seriously, this is the secret sauce that makes your favorite apps feel so incredibly snappy. And today, we're going to pull back the curtain and see exactly how it works.
You've been there, right? Staring at that little loading spinner, just waiting and waiting, wondering why one app can find what you need in a blink while another takes forever. Well, a lot of the time, that difference between instant and agonizing comes down to this one powerful database secret.
The core problem here is just scale. Modern apps are dealing with an unbelievable amount of data. We're talking millions, sometimes billions of rows of information. So trying to find that one specific thing you're looking for, it's like trying to find one specific grain of sand on an entire beach.
So how in the world does a database even begin to tackle this? Well, if you don't give it any help, it's forced to do what's called a full table scan. This is the total brute force method. Imagine I told you to find one sentence in a giant novel, but your only option was to read the entire book word for word starting from page 1. It's not just slow, it's completely unsustainable as data grows.
And this is where our hero, the database index, comes onto the scene. At its heart, an index is a special, separate data structure that's designed for one thing and one thing only, making data retrievals super fast. Instead of reading the whole book, the database finally gets a shortcut.
Honestly, this is the absolute best way to think about it. The main database table, with all its data, that's your huge 1,000-page textbook. Without an index, you're stuck flipping through every single page. But a database index, that's like flipping right to the index at the back of the book, looking up your topic and getting the exact page number you need to go to.
And that's pretty much exactly how it works in the database. Instead of grinding through every single row, one by one, the system just looks at the much smaller, neatly sorted index first. That index has the value it's looking for and a direct pointer, our page number, that points to the exact location of the full data record in the main table. It just jumps straight there.
And the impact on performance here isn't just a small tweak. It is absolutely transformative. A well-chosen index can take a query that used to take seconds or even minutes to run and turn it into something that finishes in milliseconds. That's the difference between an app that feels broken and one that feels like magic.
Okay, but it's not quite as simple as just adding an index. Not all indexes are created equal. To really use them effectively, we have to understand the two main flavors they come in, clustered and non-clustered.
So a non-clustered index is exactly what we've been talking about with our book analogy. It's a separate list of pointers, just like the index in the back of a book. You can have a bunch of these on a single table. A clustered index, though, is totally different. It actually dictates the physical order of how the data is stored on the disk. The best analogy for this is a dictionary. The words aren't just indexed alphabetically. The words themselves are stored alphabetically. And because data can only be physically stored in one order, a table can only ever have one clustered index.
Let's break down these key differences. A clustered index is often faster because the data itself is the index, all sorted and ready to go. This makes it amazing for range queries, like, say, finding all sales that happened between Monday and Friday. A non-clustered index, on the other hand, always has that extra step of looking up the pointer and then going to find the data. But the huge advantage is its flexibility. You can create many of them to speed up all sorts of different lookups.
Okay, let's look at a really practical example. Say we have this non-clustered index on the department column. If we need to find all the employees in the HR department, the search becomes ridiculously easy. The database doesn't even look at the main employee table yet. It just scans this tiny little index, finds the 2 HR entries, and gets direct pointers to rows 1 and 4. That is efficiency.
Now, all of this sounds incredible, right? Which, of course, leads to a very logical question. If indexes are so great, why don't we just index everything? And that brings us to the really crucial trade-offs.
It seems like the obvious solution, doesn't it? If we want every possible search to be lightning fast, let's just slap an index on every single column. But, as with almost everything in engineering, there's no such thing as a free lunch.
And here is the price of that speed. While indexes make reading data incredibly fast, they actually make writing data slower. Think about it. Every single time you add a new record or update one or delete one, the database has to do double duty. It has to update the table, and it has to update every single index. That write penalty, plus the fact that indexes take up extra storage space, is the trade-off we have to make.
But even with those costs, the payoff for choosing the right index is just astronomical.
99.9%. That's the real runtime reduction a study found after optimizing just one slow query with the right index. A process that took maybe 10 minutes now takes less than a second. That is the incredible power of strategic indexing.
And this really gets us to the art and science of good database design. It's never about just indexing everything. It's about carefully, strategically selecting which columns to index based on how your app is actually being used, how it queries the data. The goal is always to speed up your most common read operations while having the smallest possible impact on your writes. It's a balancing act.
And just to give you a taste, beyond these basics, there's a whole world of specialized indexes out there. The B tree is kind of the default, the all-around workhorse. But for specific problems, you need a specific tool. Need a super fast lookup for an exact email address? That's a hash index. Searching for keywords inside a blog post? You need a full-text index. And finding all the cafes within a mile of you? Yep, that's a job for a geospatial index.
So, what's the big takeaway here? It's that an index isn't just some minor performance tweak. Proper indexing is a fundamental cornerstone of building modern, fast, high-performance software. And understanding how to balance their incredible power against their hidden costs is an absolutely critical skill for anyone who works with data.
And that kind of leaves us with one final big question. As the amount of data in the world continues to grow exponentially, how do we possibly keep our searches instant and scalable? The core ideas behind indexing are our best weapon, for sure, but figuring out how to evolve them for the future, well, that's one of the biggest and most interesting challenges in all of technology. Thanks for joining this explainer.